So with the topic of the conference, I proposed a contribution to the notion of closeness and distance because the title was Crossing Closeness and Distant Readings. And Isabel suggested that I compared that I contributed with the notions that have been developed in the Latin paleography. And I'm aware that I'm a bit of an outlier in this conference because I'm not working with Papyri. And I will try to convey the evolution of Latin paleography in the last decades and open the discussion to see if something is relevant for papyrology. So in the field of Latin paleography, the question of measuring the script has been debated heavily since the 1970s. In 1973, Leon Gélissen published his expertise on medieval scripts, which led to debates first with Ezio Ornato and Albert Denens and some others. And in his expertise, he suggested to measure the angle, the form, the dectus, the model, more specifically the rapport modulaire, so the relation between height ascenders and the core of the script, and the weight of the script. In the late 90s, there was a very stimulating debate in Scrittura e Civiltà based on the declaration of Bernard Bischoff that paleography was becoming an art of measuring the script instead of an art of feeling the script. So at this time, the larger part of the Latin paleography discipline was rather supporting the idea that you should analyze script not as a measurable object, but rather like an art object. Nevertheless, the development of digital humanities at large changed drastically the position of the whole community. And since the let's say 28 and beyond, a large part of paleographers, even those who do not, strictly speaking, measure the script, have applied measures or metrics to the analysis of scripts, or at least reflected on how you could have objective clues to distinguish different writers or different script styles. And I've included Mark Smith in this short list of Stansbury, Misrael, Gurado, because he contributed in the Grapheme project, which was about distinguishing script classes with the aid of computer methods. What was all that about? The expertise from Gélissen declared that he wanted to replace the global impression with measurable and objective features. And what is of interest to me in that is that what he called measurable features are by definition local features, things that you could see and measure with a ruler, compare and measure the slant of a letter, and not just being satisfied with larger statements like slanted or rounded script. So this is one part of the discussion in the field. Another part of the discussion is what it means to detect or analyze that two script samples are from one single scribe. So there was some discussion and developments about the notions of script classification and writer identification. And I believe that we agree now that script classification and writer identification are two tasks, the same task at two different levels. So writer identification would be a close reading of the script and a local analysis, while script classification would be a more distant view on the scribal, on the written cultural heritage, and if more distant, then perhaps also more global. But global in the sense of history, not obviously, not mandatorily on the way we have to analyze the scripts. And between the single individual, the writer, and the larger script class, you have anything in between scriptoria, milieu, countries, time periods, shorter or longer, that you could define and debate. In the world of Latin paleography, of course, you have some of the same mechanisms that you have in papyrology and that Professor Fone has demonstrated in the previous talk. So you may have one scribe with multiple scripts or script types. And on top of that, you have to distinguish what the people in the Middle Ages or in antiquity defined as different script styles, and what we as historians would define as different families and types. And this advertisement poster from the scribe Joan van Hagen, which you can zoom in here. You have different scripts. They are all from the same hand with a master calligrapher. And the basis for some distinctions in his poster are very small and very little changes. Here on the right side, you see the difference between normal textura and the textus prescissus. This is the only difference is the treatment of feeds. So if you want to specifically analyze the difference between the two script classes here, you would probably need very local features to distinguish the scripts. So we have three main questions here. The question of measuring and having a locally measurable feature. Then the notion of distance and closeness in the history of scripts, and also the notion of distance and closeness within each script classes to distinguish between script classes. So these are the main theoretical points I'm basing on, and now I will provide an overview or some reflection on the developments in Latin paleography in the last 10 years. So for me, the base of this present talk is a talk that I have given with Maria Gurado 11 years ago, and I took the slides and I started thinking what has changed until then, since then, and how does it relate to the question of closeness and distance reading. What you have on the left here is the outline of the talk we held with Maria. We wanted to we first defined some global and local features and introduced yes, we introduced the question of graphonomics, and today I will introduce the question of AI and graphonomics. So at the time, Maria, with her tool named Graphoscopes, introduced to the paleographers some measurable features in the very sense of Léon Gélissen. So the first one you can think about is, of course, the line and measuring, for example, the interlinear space and layout, all the analysis of mise-en-page. At the time, we really needed some tool to measure directly by hand, if I can say so, on the image. Now this part has been completely is completely automatable. Of course, we have to be aware that our measures are pixel-wise, so we always have some calibration issues. But the main perk of this automation is that we can extend this measure to all pages in all manuscripts. So just an example, random from a book of hours in one of my corpora, you see how image analysis is able to detect all lines on the page, and you can easily prompt the software or enhance it to distinguish between the core of the script line and the ascenders, descenders, and have a value for the interlinear space. In this example, what I like is that this sort of analysis helped me realize that there was a change in the number of lines within the manuscripts without a change in the justification. So there was a change in the line height, which no paleographer, I guess, would have spotted unless he or she would have undertaken an immensely time-consuming analysis. So with these simple mechanisms of line detection, you can work and study the changes in layouts. Here, for example, this is a slide that's shown in the Codicological conference in Tours last year. And so this is largely a solved problem for paleographers. It's and this feature of layout and line analysis is generally considered as a global feature in script analysis. Another feature that you can analyze and measure is spacing, so the mise-en-texte in manuscripts, and you can study word and character spacing. This is until now not completely automatable. I've published a paper on that in 2020. I know that Mark Faulkner and some other colleagues are working on that. You can, you may hope that handwritten text recognition will provide you with the needed information, but actually until now it's not exactly the case for some technical reasons that handwritten text recognition works mainly at line levels and do not really produce character or word coordinates. If you are using a scriptorium or transcribers, for now you don't have this word and character coordinates. You just have a transcription on the line. So you would need some more specific tools to be able to measure the interword space or the inter-character space. The illustration on the right has been produced with the software Oriflammes that was developed in a project funded by ANR. A third feature that Maria was measuring with her graphoscope tool is the writing angle, so the angle between ascenders and descenders with the horizontal line. And it's not at all automatable right now because you would need to spot the letters with the ascenders, distinguish them from the letters that have upper parts which are not considered by paleographers as ascenders, like looped D. And this is something no one has really worked on, but Maria has shown how valuable this measure is, for example, to study the evolution of scripts. Here you see 4 time periods where she studied the angles of ascenders and descenders, and she was able to classify scripts according to this angle. And with Léon Gillissen, I tend to believe that these angles can also be a part of a writer identification discussion. So this is something that is not solved, and that there is space for improvements in that. Now, if we consider specifically image analysis, we have to define what we call close, local, and distant global features. Features in image analysis are generally linked to perceptive models. You can define them according to contours, density, ink distribution, or critical points like maxima and minima, which would typically correspond to ascenders and loops. In computer or in document analysis, it was very common to distinguish between global and local features, local allowing for specific statistics, and global would be more generic, like texture or luminosity or density. If we consider density as a factor and an analysis factor, Maria also has shown that there is, in specific time frames, you can demonstrate a linear chronological evolution, proving some mechanisms or changes in the in the scribal culture of a time. So the question of density, if you tune your system to spot only the written regions, it's basically also a solved problem. It's just distinguishing a letter, so the front written space from a background. Other features which were very common at the start of the 2010s, like contour, are now less commonly used. So to explain what this contour feature, which is a very local feature, is, you can take, for example, the Freeman chain code. The Freeman chain code is a representation of the succession of orientation when you are writing a stroke, but what you are taking is not exactly the succession of this orientation of the stroke itself, but of its contour. And here on this next slide, you see that you are extracting connected components that are actually the silhouette of the letter and not the letter itself. So it's a proxy for just describing a graphical feature of any letter form. If you take this orientation and successions, you can compute metrics for all directions that are used in a specific script and try to compare scripts and artifacts with this metric. Another metric that was used at some point in the grapheme project was the co-occurrences. So any combined statistics of any 2 points on the image which were deemed to be related in any way. Here, this illustration comes from Franck Le Bourgeois. and Franck tried to compute co-occurrence matrices for all features like curvature, orientation, gray level dependencies, etc. The results were not very excellent, but the idea is still valid, and I will show that in a moment. Another locally extracted feature that was used in the Graphene project was the extraction of fraglets and the constitution of codebooks. In the Graphene project, that was done by Annie Daher, but other computer scientists have developed codebooks of fraglets like Lior Wolf, who studied the Cairo Geniza. So this Freeman chain code, codebooks, co-occurrences, they were at the start of the 2010s, mainly are in average efficient, but not enough to distinguish between writers. In the meantime, two other local features have been used, and one that is mildly efficient is the SIFT features that are used by the team of Vincent Christline and some others. SIFT features are scaling variant features transform. They are taking local interest points, and so do the local binary pattern LBP features. But here I'm introducing a paradox. In the LBP features, L stands for local, but the result of this local analysis is mainly a texture description, and texture is in computer science generally considered as being a global factor. So with all these local features that we can now measure from directly based on the image, we are already mixing local and global features. That is, we use local features to create global metrics on any image or to distinguish or compare images. So this leads to my third part on writer identification at scale with the aid of artificial intelligence, and also with the notion, well, I'm introducing the notion of the merging of local and global features in neural networks. And why would I do that? I will introduce some experiments that were done based on Vincent Christline's, on Angelos Nicolaou's local features to perform writer identification or script classification, and also introduce neural networks that were used to distinguish between writers and script classes. And what is of interest for the discussion today is that the neural networks that are applied basically now in machine learning as a standard structure are mainly based on mechanisms that are apt to capture local features, and the convolutive layers are really thought as tools to capture local features. But in almost all current architectures, you have pooling layers or recurrent layers that contribute at the end, after having analyzed all the local features in image patches, to create a global representation of an image. And the comparison that we are performing between images is then subsumed, pushed up at a higher global level, at the point that we really may ask if it's still making any sense to distinguish between global and local features in writer identification. So my first case study is the analysis of the images from the French Royal Chancery based on LBP, so the local feature extractor I mentioned earlier, and it is apt to distinguish as well writers in this large dataset as some different script types, because it collocates some writers that have specific styles here, Hybrida script in the Parisian registers at the end of the Middle Ages. Another case study that is using the SIFT features is also based on the images of the French Royal Chancery, and Vincent Christline analyzed the images, and I compared them with the paleographical analysis of Jean Guiraud. And here, what is two main points are to be said. One is that the automated analysis and writer identification is probably more reliable than Jean Guiraud's assertion for some images. So that's a very important point. And the second important point I want to underline is that Jean Guiraud only attributes images to scribes. So even if he worked on a local base with a close reading, what he published is like a global reading, a distant reading of his paleographical analysis, because he never published the criteria he used to distinguish between writers. A third case study is an experiment I did by training a VGG19 network that was pre-trained with ImageNet. And this network was able to distinguish between different script classes, and also, even if less reliably, between different scribes. And now I want to underline that VGG19 is typically in this situation and describe that the deeper layers are used to capture local features and to leverage them from the input data, but it includes multiple layers of deep convolution and also pooling layers, so that at the end it's producing some sort of a higher global representation of the image. And then at this level, it is mathematically impossible to go back and to distinguish between the local features and the global features that are extracted. We just have one output of different features matrix. Something that I haven't tested by myself, but which is very en vogue right now, are attention-based systems. And attention-based systems are also something that is very paradoxical, because you would one could consider that attention-based is typically using local features because you have to take some parts of the image to construct your attention map. But in computer vision, most theoreticians consider attention-based systems as being a global feature extractor. So I will not go deeper into that, just pointing out to the paradoxes that are relevant for our paleographical discussion. So if we now go back to scripts.
We are reaching the limit of time, so I don't know if you could conclude.
Yes, I'll jump very easily to the conclusion. Now I've demonstrated that you have global and local features, and we have to go back as paleographers to letters and allographs. So what was done before was doing statistics on how allographs were distributed either largely on the scripts or within each scribal chain. And those images from 10 years ago, like how you would consider Unschel, Ds, and other allographs, are now also transmitted into other paleographical discussions, but now based on hyperdiplomatic editions and paleography, mainly based on HTR with an imitative output. Examples of that are by Mike Kestemont and Sebastian Dos Miller. So this is just going back to either letter or letter forms or letter parts. I can also quote Mark Smith and Peter Stokes on this modeling. And this whole discussion now leads to a letter level and below letter level analysis. And one prominent example is the learnable typewriter by Mathieu Aubry, and there is the work done by Madame Atenia Vlachou-Evstasiou, who is a PhD candidate supervised by Mathieu Aubry and myself. And so we are going back to very local descriptors as a sense of being able to communicate the results and the analysis and comparison between writers or between script classes. So this is an overall evolution of what has been done in the 10 last years. That is, we moved more and more to a global perception, and now we are moving back to some local descriptors to be able to discuss among paleographers with the results of image analysis. And we still haven't used really some other features like the rhythm that can be extracted with fast Fourier transform. But this is an open field. My main conclusion is that we have now completely developed a blended reading rather than a clear-cut distinction between local and global. So this is my contribution to this conference on close and distant reading. It's blended in neural networks, it's blended in paleography. Neural networks are just reinventing a wheel and will drive so much faster that we are developing this mid-level approach to communicate and demonstrate. Thank you.